Swayam Prabha. Digital India. Educated India.
So, in today's class we will be taking a look at diffusion models and with a specific example on how we can model some existing scenarios, how do you estimate parameters and fit our diffusion models. We have seen a stock flow representation of the diffusion model where we divided the total population into two: potential adopters of the product and the adopters of the product. An adoption rate or the sales rate will move people from potential adopters to adopters, driven by the factors of contact rate as well as probability of buying I. So, the equations are shown. So, you can see AR is C into I into P into A by N. The total population is conserved, N is equal to P plus A. So, in this model, the key thing that you have to understand is, as soon as one person buys a product, eventually everybody will buy the product. So, the model will run until the potential adopters become 0 and adopters is equal to N. There is nothing stopping them in preventing them from stopping halfway. So, here as soon as one person buys a product, then P more potential adopters will eventually buy the product. Now, let us see how we can use it for more real examples. Suppose the sales rate, that is the units per year for each quarter, is given in the following table. The sales record is from 1981 to 1987, quarter 1 to 4 per year, and the units per year is given, and when we plot it, we get a sales rate graph as shown here. That is the units per okay. So, step 1 is, once we get the data, we visualize what we want. So, the data here shows a kind of a bell shaped pattern. It increases, peaks at around 1984 third quarter, and then it falls down and kind of hits 0 at 1987 fourth quarter. So, that is the data that has been provided to us. Now, we would like to see how we can kind of simulate this kind of behavior using the diffusion models that we have learned. The first is to map it. Let us just make the observations. Sales data follows a bell shaped pattern. In that case, it is reasonable to think that the diffusion model might fit this data. So, what we have is sales rate, this is nothing but the adoption rate, that is obvious. Then what will be the cumulative sales? We are going to map it to the diffusion model. The diffusion model, we have seen the terms adoption rate. So, in our example, that is the sales rate. So, what will be the cumulative sales in our diffusion model? Owners or the adopters, the model wages define adopters, so that will be our cumulative sales. So, if it is indeed a diffusion model, then this adopters or cumulative sale need to represent a S-shaped pattern. Now that the sales rate is and cumulative sales rate, we know that sales rate as it increases and then the sales rate is decreasing, the underlying graph has to be S-shaped, correct, it is intuitive. But we can go ahead and plot it and see also what happens. The first step is we are going to do is, we have the sales data, that is only data we have. Based on that, let us try to figure out what is the cumulative sales data, plot it and see what is the curve. Then we will figure out how to estimate the parameters Ci, initial value of potential adopters, initial value of adopters, the total population N. Okay. So, let us do that. For that, I urge you to download the Excel file and open it. The data whatever we saw is given. So, column B is given to you, and based on column B, if you scroll down, the graph is also plotted, which is nothing but the sales rate. We have plotted those two values right here. Okay, nothing else to do, just observe what is there in the field. Okay. So, first thing we are doing is the actual sales data gives it which year and which quarter and things like that, but of our computation simulation purposes we can reset the scale to 0. Okay. So, the time starts at 0 and then since it is every quarter we can just make it 0.25, 0.5, 0.751 and so on, and that is what the reset time column is put. Okay. Though we have data until only to 1987.4, we are just extending it for a few more data points, which is fine. So, all we have done here is reset the time starting at 0. Now, in this sense, this is a slightly tricky example. The units of sales rate is units per year, whereas at every quarter I am selling what is the quantity per year. Okay, but what we want is what is actual quantity sold in that quarter. So, to compute that, first we divide sales, that is units sold in that quarter, as should B2 by 4. Just note it, the equation you see will be incorrect, you just change it to, it should be B2 divided by 4. See, what happened is kind of, it is like you are accounting for that in a simulation time step or the level of accuracy. Every quarter they are reporting what is the sales rate per year, but what you want is actual quantity that is sold in that quarter. So, since each year has 4 quarters, we are dividing the sales by 4. So, let us just divide it. So, it is B2 by 4 and you just drag the column all the way to the end. Now, got it. So, sales is nothing but units sold that quarter is the total units sold divided by 4, that is the quantity sold in that quarter. The cumulative sales, the first value is 0, the second value is, when formula is given, it's nothing but current cumulative sales plus whatever has been sold in that quarter. So, the second row you can drag it to the end, you will get cumulative sales column is 7900. So, all of you got this values. So, all the steps that I am telling you right now is also written on the right side of the sheet. Step 1, rescale time. Step 2, get the quarter wise sales, column E. Step 3, calculate cumulative sales, column F. Okay. So, now just stop there, up to column F is sufficient. So, if you scroll down after doing column F, you will see a right side graph. I mean, the formulas have been pre-filled for you, so as soon as you put your numbers, the graph will show this figure. So, this right side graph shows the cumulative sales data or the total number of adopters over time, which is a classical S shaped. So, it looks like we can fit a diffusion model to see how well we can fit it. Just hold on to that so that you understand what you are doing. There are so many spreadsheets. Now, we need to pretty much estimate these parameters Ci, P0, A0 and N from the data that is given. To estimate these parameters, we need to look at a bit of maths. Let us go ahead and do that. So, we are going to go to the equations. Diffusion model, analytical equation. It's going to be a pretty lengthy derivative. So, you can get started. We have seen that the adoption rate AR is equal to C into I into P into A by N. So, this is what we had seen from the equation. So, whatever is the sales rate or the adoption rate is the same rate at which my actual adopters change. So, this is nothing but the change in the number of adopters A. So, you want a smaller equation. What I am plotting here is this model. For simplicity sake, I am just going to do it C into I is this. Okay. So, this is the model and the underlying equation is shown. So, the change in A same as C into I into P into A by N. We know that P plus A is equal to N or P is equal to N minus A. So, we can rewrite our dA by dt as C into I into A into N minus A by N. So, remember what we did to solve for when you had exponential growth or asymptotic growth, we try to solve the equations and to try to figure out what is the analytical solution for it. We are going to do a very similar thing right now. So, we would like to solve this. So, this let us just denote it as equation 1. Solving, let us say dA by N into dA by A into N minus A is equal to C into I into dt. Integrating it on both sides, let us put it like T naught into T, I am going to get N into dA by A into N minus A equal to T naught T C into I into dt, which then gives me okay, just continuing the last equation, I am just integrating it. So, which gives us log of AT minus log of N minus AT minus log of A naught minus log of N minus A naught equal to C into I into T. So, T naught is at time 0. So, the last term disappears. So, this can be rewritten as log of AT by N minus AT minus log of A naught by N minus A naught equal to C into I into T, or log of AT by PT minus log of A naught by P naught equal to C into I into T. Let us call it as equation 2. Again I can play with this main equation as per my convenience. So, this can be further solved or to give us another expression as at by n minus at is equal to e power cit into a naught by n minus a naught. Let us call it equation 3. And we do not need to go through this to get it here, just from here we can get this expression. So, we can get it from here, we can compute the expression for at. So, what you are trying to do is trying to come and solve for at. This is just intermediate step, we can view it in this form or we can expand further. N minus at is nothing but pt, I just want to reinforce it, that is why these are so equivalent, either I represent as pt or n minus at. I can remove logarithm by raising to the power e, which is what I did in equation number 3. Can actually solve for from this equation, I can directly solve for at to get at is equal to n divided by 1 plus n by a naught minus 1 into e power minus c I t. Let us call it equation number 4. So, from 3 I have at and n minus at, you can take n minus at the other side, multiply, then get it over the other side, take a common factor of at, then again go it back, divide it, and if you solve you will get this expression at is equal to n by 1 plus n by a naught minus 1 into e power minus c into t by into c into I into t, first t is the time. So, in this equation if you see, initial value of adapters is required, thus initial value of adapters 0, there is no diffusion model happening. So, there has to be initial value of adapters. As soon as the initial value of adapters is going to be there, this equation will come into effect. C is known, I is known, n is known, a naught is known. So, all the parameters are known. The only thing that changes here is time. So, as we progress with time, we can compute value of adoption rate or the not adoption rate, adopters, or in our example it is the cumulative sales. Based on these equations, we already come to so much, we can actually ask some very basic questions on when net adoption rate reach maximum. We have taken it as from 1 adoption rate is already given as c into I into a into n minus a by n, which is a minus c into I into a squared by n. Taking first differential and set to 0, we can get Ci minus 2 into c into I into a by n equal to 0, which gives us a is equal to n by 2. So, when a is equal to n by 2, it is going to reach the maximum. You can take second differential. If you do second differential, you will find it is a negative. So, that means it is a maximum point. So, but when does this occur? At what time will this occur? At what time will this occur? How will I find it? What time will it occur? To figure this out, Substitute at is equal to n by 2 in your equation, what is it, in your equation 4 and solve for t. So, substitute at is equal to n by 2 in equation 4 and solve for it. This is equation 4, this is equation 4. So, substitute at is equal to n by 2, solve it for t, and you will get t is equal to 1 by c into I to logarithm of p naught by a naught. So, this is the time at which it is going to hit the maximum.